You're looking live at the Ares I-X rocket on pad 39B at NASA Kennedy Space Center. You're watching NASA Edge. Hey, welcome to NASA Edge.
An inside and outside look at all things NASA.
In a new format. We're actually live today for the very first time.
And unscripted.
Which is normal.
Which is scary because you being live and unscripted at the same time scares me and Jackie.
Editing usually saves them.
Yes, among other things. And who knew it'd be dark at 7 a.m., by the way?
That's right. And in fact, for those of you out there who have never heard of NASA Edge, NASA Edge is an unscripted video podcast that takes an inside and outside look at all things NASA. And Jackie, why don't you tell them how to access the podcast?
All you have to do is go to www.nasa.gov/NASA Edge. You can also download the episodes on iTunes.
Which I recommend, by the way.
And on the show today, if you want to send in a question, you can send a question about Ares I-X or NASA in general to nasalearn@gmail.com, or if you're a Twitter fan, just Twitter to NASA_Edge.
And we are monitoring Twitter closely because we want to get all those questions in throughout the show and throughout the day leading up to the launch.
Actually, let's go ahead and get started with the show, and I'd like to introduce Michelle Ferebee. She is the Aerospace Education Services Project.
How you doing, Michelle?
Good morning.
So what is ASP all about?
It's all about teachers and students. It's all about 22 educators at all NASA centers that are doing educator professional development and student programs in all the 50 states and U.S. territories.
Now there's 10 NASA centers throughout the country?
Yes.
Okay.
And we're bringing exciting programs, robotics programs, bringing that NASA content, getting into the hands of students and teachers so that we can inspire our next generation of explorers so that we can go to moon and then on to Mars.
Now, are these trained, they're the trained NASA educators that will go out into the schools to work with the teachers and the students?
Yes,
okay.
Exactly.
And so kids today actually in the schools might be watching this program right now, being inspired.
Exactly.
So don't listen to me, listen to everyone else so that you can be inspired, because this is an incredible event we have here today with Ares I-X.
Now, how do, as a teacher, let's say I'm a high school teacher. Actually, I am a former high school teacher. How do I contact an ASP educator to come to my school?
Well, you can do it different ways. One way, of course, is to go to the NASA website, to nasa.gov/education, and find AESP. Also, a lot of our education specialists go out to the schools and reach out to the science supervisors and the math coordinators within all the school systems.
And this is a free program?
It's a free program, and what else can I say?
Can you get like special credit if you're not doing well in one of your math classes and you get signed up? Can you get some help, like me, maybe?
Well, you know, some of the teachers might on the side for a small fee give you a little bit of tutoring.
I represented all the tutoring opportunities in the school system, that's for sure.
Right, but this is the front line. This program is actually the longest running K-12 program in NASA.
Oh, wow.
It's been in existence for almost 50 years.
Wow. 50 years?
50 years.
You remember that, 50 years
ago?
So
you target all teachers K through 12?
We target all teachers K through 12, and starting 2 years ago, actually, we've started working with pre-service teachers that are still in college, third and fourth year college students, to try to get them used to using some of the NASA content before they hit the classrooms.
What kind of NASA content do you talk to them about?
Everything, for example, anything associated with Ares I-X, for example.
Nice.
We have programs surrounding L-Cross.
Oh yeah.
And impact of the moon.
Exactly.
Right, and we're actually looking at some real data in some classrooms when that happened, I believe.
That's correct.
Yeah.
That's correct.
So pretty much you stay up with all the current NASA topics and the current NASA missions.
Yes, that's correct. So people like you, the education public outreach people that are working in the mission directorates, our educators stay in touch with you all and talk to the scientists and engineers to try to make sure that a lot of the public outreach information is also usable in the classrooms. We have lesson plans and curricula that are aligned with the national and the state standards, and we'll actually tailor our workshops to the needs of the particular schools that we go in and try to support.
So it benefits everybody, basically.
It benefits everybody.
And what better way to get real content, real data that you're using in the classroom, so when that student goes up to the teacher and says, well, I have to learn about algebra or about physics or chemistry, I mean, we can answer those questions.
Exactly.
That's awesome.
Do you find that the teachers are just as excited as the students?
They really are. They really are. And we want to try to come up with some new programs to try to get the teachers more immersed in what the engineers and scientists actually do, so that they know more about why the students are learning, as opposed to just going in and just having to do the rote teaching.
That's cool.
Well, Michelle, I want to thank you so much for being here today. We have to take a quick break, and when we do, we'll be back with Jill Marlowe, who's her title.
She is the Deputy Director for the Systems Engineering Directorate at NASA Langley Research Center.
At NASA Langley. And we'll actually be talking with her and coming back with questions.
Cool. Thanks, Michelle.
Well, thank you. Go Ares I-X.
Absolutely.
Congratulations.
Thank you.
7825, code 6, 105 North Avenue, 52.
I think he's going to want to see a license and registration.
Well, we don't have a license and registration for a test article.
Well, look, see if we can find something. Maybe we can find Mike Bernhardt's thesis for this system.
Oh no, here he comes.
Let me do the talking.
Hello, officer.
Sir, do you know how fast you were going?
Hi, officer. You need here on Earth or on the moon?
Sierra 3 dispatch, I've got a runner. Looks like they're going to make a left on 5th Street.
Yeah, well, you shouldn't have used the co-host as your character witness.
Well, you're certainly right about that.
Come on, let's get this place cleaned up.
You bet.
We're back with NASA Edge.
An inside and outside look at all things NASA, and as you've just witnessed an aspect of the live production where I wasn't paying attention to what was going on.
Yeah, but that's okay. It's the first time we've done this, so we'll see how
I
it
actually
goes.
was watching the live feed on the computer, which is slightly delayed, so I got a little distracted. But it won't happen again, because with live programming, you actually learn.
That's true.
So I'm learning on the job.
Well, let's get to the meat of the program today, the Ares I-X launch. And this is going to be an exciting launch today, hopefully.
Absolutely.
That the weather holds out, because for the first time, we have a different vehicle on pad 39B other than shuttle.
Right.
Which is
In a long time.
Which is amazing in and of itself. I mean, it's been since Saturn launched.
That's
on
right.
it. So it's been over 30 years at least.
This is actually my very first launch ever. Not to mention the fact that I've never known another vehicle, so this is extremely historical
For Jackie.
for me.
For
the NASA
everybody. That's
program,
right.
absolutely.
And in fact, we have an expert to my left. We have Jill Marlowe, who is the Deputy Director for the Systems Engineering Directorate at NASA Langley Research Center, which we're based out of.
That's right.
And Jill, welcome to the show.
Thank you. I'm so excited to be here.
It's pretty cool to talk to an engineer who's actually worked on the rocket.
You want to touch me?
Oh yeah.
Yeah, I mean, let's talk about that a little bit. Let's talk about that, because you were intimately involved in this project coming along. So how does it feel to be right here on the brink of the launch?
You have no idea. I mean, this has been 3 years in the making for so much of the team. I was privileged to be a part of it for a short time, but it's like you just said, this is so historic. This is the birth of a whole new human space transportation system. And the kids who are in school today probably won't even remember shuttle. They'll remember this. And anybody who's watching will get to say they were there from the very beginning. This is the first test flight leading up to a whole new series of rockets to get people to space.
And for the fans out there, we actually have a pretty cool animation that we're going to show you on how the Ares I-X rocket will launch. And Jill, let's take a look at the animation and kind of run through what's going on here.
Very good. So there's our rocket. It's 327 feet tall, 32 stories. It was made all over the country, sliced up like a hot dog and then integrated together, which is no small feat in and of itself. And here it is blasting off. There's a little maneuver to kick it away from the tower to avoid damaging the tower. That plume is really powerful. And now it's completing its liftoff maneuver, which is one of the most intense parts of the flight. Now here on ascent, one of our flight objectives is to show that we can actually control this new rocket configuration, and it's executing about 4 different maneuvers where we basically steer the rocket in a known way and then see if the rocket will react exactly the way we thought it would. And now it's coming up on its 130,000 feet, where we'll actually separate the booster from the CM-LAS and the upper stage, the upper parts of the rocket.
Can we pause the video for a second, Ron? Now I got a question. Now this saw first stage separation. Now
yes,
where are those thruster firings down towards the end of the
back end of the rocket?
Back end of the rocket?
Well, there's actually 2 different sets of little rockets back there. There's the booster tumble motors and the booster deceleration motors. The big ones that we saw fire just a couple of seconds ago are the booster deceleration motors, and their whole purpose is to actually slow down the booster so that the rest of it can continue on and they won't come into recontact, which would be bad. And then the ones that you can see frozen on the screen right now are the booster tumble motors. You see they're only on one side, and it actually helps the rocket to spin in a certain way as it tumbles.
And we'll see that in a few seconds.
And you'll see that in a few seconds, yeah.
Okay, let's go ahead
that's very important to know, because you're wanting to control that landing, but not so for the first stage.
That's right.
Or
that's
upper
right.
stage.
The upper stage and the tip of the rocket will tumble into the Atlantic and break up, and we'll see that in a minute on the animation.
Okay, let's go ahead and continue the animation if we can.
There it goes. So those little rockets are causing it to tumble. And
Gotcha.
actually, it's a carefully designed tumble. If it doesn't slow down and tumble exactly right, our parachutes won't open.
Okay.
And if the parachutes won't open, it won't stay intact and we won't be able to recover the booster, which is another one of our primary test objectives.
And we learned all that during the shuttle, so we know how to reuse these
That's right. And actually,
SRBs.
That's right. And this one is actually assembled from pieces of prior SRBs from 30 different shuttle flights.
Wow.
Wow.
Now this upper stage.
It's like a big Lego set that you kind of.
now the upper stage
Just
in
like
the
that.
the crew module and launch aboard system will just fall into the Atlantic Ocean. It's a mass simulator.
Yes, that's exactly right. And it's actually designed to break up out there.
Okay.
Are there any eyewitnesses that we have planned to see it happen, to monitor that? Or?
You know, I don't actually know if we're monitoring where it goes in visually, what you mean.
Well,
No.
because it's a fine line. I mean, you want to be safe, but that's going to be coming in without a parachute. So,
Yeah. Well, the range is cleared, so it's clearly safe.
We see the parachutes deploying for
right, that was
the first
pilot.
stage.
Yeah, that was the pilot chute, and here come the main chutes, and they'll fully inflate in just a second.
Now, since the solid rocket booster is a 5-segment solid rocket booster as opposed to shuttle uses a 4-segment, the parachutes on this particular SRB are much bigger than the ones from the shuttle.
Yeah, and there it goes. It's coming on in, and it just ejected the nozzle, and now we'll get to see it land, and look, it's completely intact. Isn't it nice when simulations work?
Yeah. That's pretty cool.
It is very cool.
We got to get a job where we can get some scuba gear and go and actually
I know.
retrieve that.
Those guys have a cool job, don't they?
So they really do, right afterwards, send divers in.
Yeah, I mean, I'm not as familiar with the operations segment, but I do know that demonstrating the recovery of this is one of our primary test objectives. You know, this is a whole new era in the way we're doing things, and not only is it new technically from a rocket perspective, but we're also doing a lot that's new operations-wise. So for example, right now in the firing room is a much smaller group of folks that are right there on console to launch this rocket than you ever saw on shuttle. And just that whole process is a new thing that we're also testing out.
Well, it seems to me like that's going to accelerate things. Like in the Apollo days, we're breaking new ground and just sort of learning as we go. And now it seems like we're going to be able to take the benefit of that program with the shuttle program and sort of combine the two in the new program.
Absolutely.
And get further faster.
Well, we're always trying to leverage everything that we've learned before and make good use of it as we go forward. We don't have to relearn things we already know.
Well, that's good.
Being an engineer, of course, as an engineer, you're very interested in data.
I'm very interested in data.
I mean, because that's your whole. So the thing is, with all this data, you know, you're going to be taking something like 700 different measurements.
Yeah, I didn't mention that. There's 700 different data points all over the rocket, and they actually match up to points that we studied while we were designing the rocket, and also points that we tested in the wind tunnels beforehand. So this will be a time where we get to actually compare all of that data and see if our methods are good.
That's a lot of data points.
Is that data?
It's actually not nearly as many as the analysts want.
Really?
We wanted many more.
Would they ever ask for less? I mean, aren't the analysts, don't they tend to want everything?
Yes,
right?
we were asked for quite a yes.
Okay.
But to reduce that set substantially.
Where is that data stored?
Where is that data stored? There's actually some onboard computers, and then the data is also telemetry down as the flight. Yep, up until separation.
Is that a redundancy, or is that just a?
There are redundant data units on board. Yeah.
Okay. Okay.
Well, Jackie, I think we actually have a fan video from the turn basin.
We do. Franklin is out talking to several people who are out watching the Ares I-X, waiting for it to launch. So let's see what that video is all about and see what they're saying.
What does today mean for the history of NASA?
In terms of the history of NASA, today is a really big milestone because it's the first time in almost 20 to 30 years that we're launching a new vehicle to replace the shuttle. So there's a lot of people who've never been part of this that are going to get a chance today to put a new vehicle out there.
That's a great job, Franklin, out there with his iPhone, taking video immediately.
Using the current technology at its best.
Absolutely.
Hey, I just got an update.
Okay.
You know, just like that was kind of cool, wasn't it?
Yeah. I used to be in the Secret Service, so I'm used to the IFB. So.
It turns out from our good buddy Derek Wang, he's saying that the rotating service structure that surrounds Ares I-X is being retracted.
Ah.
But it's in the park position, but we're still keeping an eye on the weather.
Yes.
There could be a case where it might get delayed because of weather, so we're going to stay tuned and see what happens.
Yep. The electronics don't like lightning so much.
Now, speaking of the weather, I happen to have a list of 15 weather conditions that will prevent the launch from taking place.
We'll look at the video. We can
oh,
see.
that's beautiful.
Oh, that is beautiful.
But anyway, if weather does become a problem, I'll be peppering the show with different incidents that might cause a reason for a delay.
Oh, I thought you were going to do like a top 10 list. I was getting all excited for a minute
Pressure's
there.
on. It's live TV. I don't have writers like Letterman or
man.
anything. Of course, that's a good thing.
So let's take a break, and when we come back, we'll check out some more fan video.
Excellent. You're watching NASA Edge.
An inside and outside to look at.
At All Things NASA.
Yes, we are. And
welcome back
to NASA Edge Live.
An inside and outside look at all things NASA.
Where the promos are a little too short for me to review all the notes that I have that I'm going over before we went to break. So sorry about that.
And
but that's okay.
I think we might have another fan video. Is that true, Ron? Oh, they're queuing that up now. But before we actually go to that fan video, we actually had a chance to talk to the deputy mission manager, Jon Cowart from NASA Kennedy, and let's see what John had to say about.
Actually, before we do that, we are starting to get some questions to come in from Twitter and email.
I'm sorry, I jumped the gun.
Yeah, you did. And Jackie, I believe, has a question from our viewers.
Sure. Will the Ares I-X rocket be used for lunar projects, and with the advances to the new rover, will it be carried in this new rocket out of there?
Interesting.
Well, so Ares I-X is actually just a test flight. It's a demonstration test flight. So it, in this configuration, will not. But it's part of the whole Ares family, which is intended to eventually carry the astronauts to the moon, and with whatever experiments that they will want to do there, possibly including rovers.
How many additional test flights will there be after this?
Oh, it's a good question. I actually don't recall the number. It is a good question. And it's actually sort of much debate, because as engineers, we want as many test flights as possible. But of course, we have to balance that with the mission that we
You like to test every day if you want to, right?
I would love to test every day. I love data. Did I mention I love data?
You did talk about loving data, yeah.
All this talk of testing is bringing up bad memories from school. So, I'd like to move on.
Well, so there's a different thing about these tests, right? Which is you even learn from failure.
Oh.
So, there is no such thing as a failure in that way. So, see, that should give you comfort.
It gives me comfort and hope. Thank you so much.
Hey, I think we have Jon Cowart's piece ready to go. So we're going to hear from the Deputy Mission Manager, Jon Cowart from NASA Kennedy.
And we're going to do, is that Franklin's interview? Or?
Yeah, Franklin's interview.
Perfect.
Right.
Okay,
Absolutely.
great.
Yeah.
Hey guys, I'm here today with Jon Cowart, Deputy Mission Manager of Ares I-X. John, give us a brief overview of Ares I-X.
Well, Ares I-X is a flight test of an Ares I-like rocket. We're flying this thing so we can collect data to give to the Ares I folks, but also, by the way, we just collect data that's good for rocket science. For the first time that I'm aware of, we've taken a computer model with test points on it, then a wind tunnel model with the same test points on it, and then an actual rocket with the same test points on it, and we'll be able to compare all three and improve our ability to model rockets. So tomorrow, what'll happen at T0 at 8 a.m., you're going to see it lift off of Pad B. It'll clear those towers in about 6 seconds, go supersonic in 39 seconds, and then the powered portion of the flight is over in 2 minutes and 4 seconds. And then we do the recovery of the first stage, and the upper stage just becomes a giant lawn dart out in the ocean.
Yeah. So why won't you retrieve the upper section?
Well, because we don't need to. All the data that we're getting, all those sensors that we have 725 sensors on this rocket, all the data is being first it's being telemetered down, coming to us on the ground. Second of all, it's being recorded, and we feed that into the first stage. We're going to recover the first stage, so there's nothing in the upper stage except a whole bunch of platforms that allow us to get to the top of the rocket, so there's no need to recover it. And in fact, we had to do a study for the Coast Guard to verify that when it hit the water, it would sink.
It would sink?
Yeah.
How many miles downrange will the Ares I-X fly?
Okay, it's going to come into two pieces. The first stage will splash down about 110 miles out, and then the upper stage will go on about 130 miles before it hits the water.
Visually, will it leave our sight?
Absolutely, it will leave your sight. You will not see either one of them splash down because separation occurs somewhere in the neighborhood of, like I said, 25 miles out, and then it just continues on in a giant arc. So you'll lose sight of them.
Okay. Where are you going to be on launch day?
Well, I'm going to be over in Hangar AE, located over in the Cape side. The primary launch team is, of course, here in Firing Room 1. It's a very small launch team of only about 30 people. But the people who are sitting in what we call the back room, or the launch support team, we're all going to be in Hangar AE. Now, Hangar AE supports a lot of unmanned launches out here at the Cape, so they have a very good history of doing this sort of thing. And we're trying to break with the shuttle tradition of having everybody in Firing Room 1 and 2, that sort of thing. So we're going to go with a small Firing Room 1, and our Firing Room 2 is now going to be over in Hangar AE. So like I said, we're trying to think out of the box and do new things.
Those data points that you talked about earlier, those are things that you're going to be monitoring from the Cape side?
Absolutely. We look at all the sensors and what they're telling us, as well as the guidance, navigation, and control, and the flight control stuff. That's actually during the countdown what we'd be looking more for is, are those things behaving properly?
Now, what is different with the Ares I-X from the Apollo Saturn missions? What's the difference in the size of the two rockets, or the rockets?
Okay, well, a Saturn V was 365 feet tall, and Ares I-X is 327 feet tall. A Saturn V was 33 feet in diameter at the base. We are 12 feet in diameter at the base. And the thing that drives that is how much mass you're trying to get into orbit. Now, obviously, a Saturn V wanted to get a command module and a lunar module, as well as an Earth departure stage, had to get all those things into orbit. With an Ares rocket, all you're trying to do is get a command module and a service module and some crew. You're not taking a lunar module or an Earth departure stage, so we don't have to be near as big, and therefore we don't need as much propellant.
Okay. Well, I'm going to step outside of the Ares talk for just a little bit. And on launch day, you know, we know you as a deputy mission manager, but on Twitter, you're
Rocky Side.
Rocky Side.
Yeah.
Which personality is going to show up on launch day?
When I'm dealing with my team, I have to be the cold, calculating engineer. When I'm on Twitter, I'm the excited guy that I really feel I am inside. So after this thing gets off the ground, I will be Rocky Side. I guarantee I'll be very excited. I'm pumped up on adrenaline. That and Red Bull.
Pre-launch, are we going to hear anything from Rocky Side?
I'll try to a little bit. I'm kind of restricted in what I can do from over there because I don't have a lot of computer connectivity. So before I go into work in the morning, I'll probably tweet something, and then as soon as I can get to a computer after the launch, I'll tweet something.
Well, you know, before I came over here, Blair wanted me to bring you something. He gave me the launch codes and the launch code key so that you can launch Ares I-X. He picked this up on...
Really?
Yeah.
Well, this is great. Now I don't have to wait for a go from anybody else. When I think it's ready, I can go.
Absolutely.
Okay, that looks great to me. I'll take it, man.
Hey, John, thanks a lot.
Thank you.
Guys, back to you.
Well, I have to clarify some things because I was the victim of some fan fraud. Somebody actually came to me and said that they had the launch code and the keys, and I didn't know any better.
I can't believe you fell for that.
I lost all my per diem. It's terrible. But there are no launch codes. There are no launch keys. They're very much more sophisticated methods than the old NORAD from war games back in the 80s.
Well, you'll know for next time.
Yeah, and I won't make the same mistake twice. It's all about learning, as Jill mentioned
all about
earlier.
data.
You go through a test, and then there you go.
I think Jackie had a question real quick.
Sure. Yesterday we had an opportunity to get really close to the Ares I-X. And Jill, I don't know if you remember what you look like, but you were so excited to see something you had worked on. And it was the first time that you had ever seen it all put together because each piece came from different centers around the nation.
Tears coming from
it was just so motivational and so exciting to see you react that way.
Oh, it was amazing to see it like that. The last time I actually saw the rocket was when it was in the VAB, probably, I don't know, 6 months ago, and it was still in pieces. And you saw in the video with the interview with John, the guys crawling up inside the rocket. It gives you a sense of just how big it is when you're up next to each other. And then seeing it all put together on the pad like that, it brought a tear to my eye. Engineers, we get emotional about this stuff, you know?
Well,
speaking
about people getting excited, I think Franklin has another video from Turn Basin. Let's go check it out.
So I understand you've been working on Ares I-X. What does the flight of Ares I-X today mean to you?
Today's really kind of the big day. It's sort of feels like graduation day. You know, I've been in Constellation since it first started, since the first concepts were developed, and now to be here on launch day watching the Ares I-X rocket, which we worked so hard to get ready for, on the pad and ready to go, is really, really a great moment. Great moment, great goosebumps.
That's awesome. That's pretty cool, isn't it?
Yeah, I'm really glad we have Franklin out there, on the scene talking to people. And it sounds like there are a lot of people out here like Jill that actually, contributed to the project. So a lot of people out here feeling a sense of accomplishment and excitement as we're on the brink of this new start.
I just like the fact that we're actually using the technology that he's actually able to send, live video to us.
Yeah, well, Franklin's been sending live video to lots of people for a long time, so it's old hat for him. But it's new for NASA Edge Live.
I do have a question though about I-X. This has been, you said a 3-year process you've been working on. I mean, take us back to that, initial day when you first started working on the project. I mean, what was going through your mind at that point, and then compared to this now? I mean, take us through that
Oh gosh, well, I actually joined the project I think it was about a year or so ago, so I was only on it for a very short time, and the design was well underway at that point, had already been through what we call a critical design review, which is where theoretically we know exactly what that rocket is supposed to look at, but we still had some major technical challenges. We haven't designed a new rocket like this in 30 years, and so we were learning quite a bit at that time. And so what was going through my mind, it was, wow, can I really do this job? And then as I came onto the project, I realized there was an amazing team. And one of the great things about an Ares I-X and any project like this is that no one person can do it. We all actually have to work together. I don't know if you remember back in school, you'd get these team projects, and sometimes it'd be like one person would do all the work, and there were some slackers. You can't have that on a project like this. Everybody is important, everybody carries a piece of the load, and you can't do it without each other. So that teaming and that coming together and everybody really needing to know their stuff and actually kicking in and covering for each other, that was just amazing. And so I feel like I did fine. I guess we'll find out in a few minutes.
It's all about the data then, right?
It's all about the data.
And weather permitting. We want to be sensitive to that. But we've got another question via email. This is the conceptual images of Ares show the second stage is covered in the orange foam, similar to the shuttle's external tank. Ares I-X is all white. Is the foam not there, or has it been painted like Columbia's first launch?
Good question.
So this is a suborbital flight, and so we don't need the same kinds of thermal protection, and it is painted. Actually, it was kind of funny. The decals that you see on the rocket, right when I was coming on the program, the decals went on. And it took us a little bit to realize that that was actually interfering with the white paint, and we actually needed to check and make sure that that was okay from a thermal perspective. So my buddy Ruth, who does all the thermal analysis on the rocket, had to run some numbers and make sure that was all okay, and it was.
Well, we want to give a shout out to Ruth. Good job. That's awesome.
Good job, Ruth.
Hey, wait a minute. Before we're actually going to